broadcast right now. Well, for starters, I forgot to mention one of my expertise uh, that I haven't shown to people recently. But maybe you have an idea on some of my videos. Well, not here in YouTube, but in Facebook. So basically, I'm also a math tutor. And I've been doing this since college as my means to gain more allowance. So, why did I start tutoring? Well, basically, the idea is I had my math senses awakened when I was in high school. And because of that, I decided to share my knowledge to people, especially to those who are totally blank in math. For some of them who had math anxiety, and to those who are totally afraid of numbers. So I was the one to encourage them to like math. So for this live broadcast, I would like to demonstrate that skill to everyone all around the world. And just recently, a post from Facebook has given a math challenge such as this. So this is part of geometry. And what we're trying to solve here is the shaded area right in the middle. If I remember correctly, in Facebook, this is shaded in blue. But since I lack of coloring materials for this broadcast, I decided to put it in black in a shade like this. So, the given is actually an equilateral triangle that is 9 centimeters long. And the insides are, of course, these triangles are also equilateral. And you have a shaded hexagon. And that hexagon is of the same size of the side of this small equilateral triangle. So how can we solve this area given only the outside measures of the sides? Okay, so since this is geometry, you have a lot of concepts to take note of, like triangle properties, especially for equilateral, right triangles that are related to that, and composite figures, as far as I know. Okay, so let's begin with using the outside dimensions to solve for the insides. Okay, for what I see here, if you look at the left and right side of this equilateral triangle, there is a hidden figure that is right here. Okay, this is actually a right triangle. So let's use this right triangle as our means to solve for the sides of the smaller equilateral triangles. So it will look like this. Okay, so we still got the 3 centimeters here, and since this is twice of that, this will be 6 centimeters. And then we have these 1, 2, 3 sides that are equal here. So since the side is unknown, we will treat that as 3 s's. Or if we collect them all, we have 3s. Okay? So it turns out that this right triangle is a 30, 60, 90 triangle. And this is a very special triangle because it has a certain property on the ratios of the sides. But we'll get to that later. Okay? So, the first thing that we can do here is to apply a general theorem or a general rule for right triangles, and that is the Pythagorean theorem. And the Pythagorean theorem states that the square of the hypotenuse is the sum of the squares of the sides. Okay? So if we're going to relate it to this one, so the hypotenuse is actually the longest side of the right triangle, particularly this one. So this is 6 squared, and then we add the two sides. So we have 3 centimeters and we have 3s. So we have 3 squared plus 3s squared. I just included the parenthesis to indicate that the entire 3s is squared. Okay? And then from there, we can solve. But there is another alternative to do this even without using Pythagorean theorem, and that is the property of the 30, 60, 90 right triangle. That is this ratio. So side opposite to the hypotenuse is just half of the hypotenuse. So if, for example, you have 2, then this will be 1. So I'm not using fractions here, just to get a direct relationship between these sides. And then if I have this, so the missing side will be this part. And to allow us to remember this easily, I can only use 1, 2, 3, right? So I have 1, 2, 3. But this 3 should be smaller than the hypotenuse. So that will be taken its square root. So we can use this property to get to the longer side of the right triangle. So in this case, this longer side is related to 3s. So we can directly get this ratio. So if we're going to directly go for the s here, so let's take it by ratio. Okay? By similarities, 6 is to 2 as 3s is to square root of 3. So you will have 6 over 2 is equal to 3s over square root of 3. This is much easier to compose. Now, 6 over 2 is actually 3. And then we cross multiply square root of 3 there. That will be 3 square root of 3 is equal to 3s. Now, obviously, by direct comparison, since both have a 3 here, then our side is square root of 3. So you have square root of 3 centimeters. Now, the ruling here is we are trying to compose the area of the shaded region. Okay? We already established the side. So we have the side of square root of 3, 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 square root of 3. Right? Now, imagine you are closing the top lid of a box. If you're going to assemble all of these smaller equilateral triangles here, then it will be composed of this one hexagon. Pretty neat, huh? So, it's exactly the same size as these 6 equilateral triangles. So, having said that, to get to the shaded area, so the shaded area will be equal to 6 times the area of the smaller equilateral triangles. So that will be 1/2 base times height. Okay. That here is the tricky part. Now, the good news here is all of those 6 triangles are equilateral. Actually, it has a special formula for the area of the equilateral triangle. So instead of 1/2 BH, we can transform this to square root of 3 over 4 s squared. So basically, using 1/2 BH, we have the base, which is of the side of the size of the side, which is s, and then for the height, that will be square root of 3 over 2 times s. That's why we obtain this formula. Okay? So, having said that, we can reduce 6 and 4. So, this is now 3 and this is 2. So, we further simplify this as 3 square root of 3 over 2 s squared. Okay? So, we're ready. So, we already have the side, which is square root of 3. So, we will have just to substitute that. So, you have 3 square root of 3 over 2 times, you have square root of 3 squared. And you know what happens if you have a square root and squared? They're actually opposite operations, just like addition and subtraction, multiplication and division. So we can cancel this out. So we're only left with 3. So this 3 will be multiplied to 3. Therefore, our area will be 9 square root of 3 over 2 square centimeters. And this is our final answer. If you want to compute this, you can use a calculator to compute for this value. So just multiply 9 to the value of square root of 3, which is, I'm not sure, that's 1.732, and then divide it by 2. And that's it. So the area of the shaded region is 9 square root of 3 over 2. And that, folks, is geometry. I hope you learned something from this video. And if I happen to have other ideas complementing to this, then I would like to share to you next time. Till then, this is Mega Vinx, signing off.